right, hopefully we'll finish 4-1 today. But keep forgetting. There we go. This probably sounds better. All right. Got a mic on me, and we are ready to go. So let's draw a picture of a triangle. So I'm just looking at my notes. Kind of looks like this, and like that. All right, and I'm gonna group it together. Let's see if it grouped. No, it didn't group. Why didn't it group? Maybe I gotta click group. Hit Control G, that usually does it. Okay, anyway, now I'm gonna copy and paste this, and I'm gonna rotate it just a little bit just to show you. If I can grab it again, let's try it. Oh, come on. There we go. Yeah, let's just do it like this. Did you hear what I just did? What did I do to this triangle to get this triangle? I copied it, right. So what do you think might be true about this triangle and this triangle? They're exactly the same, right? So if I took this one and I put it on top of this one, they would match up. Agree? Yeah. I just have to, all I did was like twist it around. Okay, I rotated it just a little bit. So they're really the same triangle. Now, we have a name for that. We'll talk about that in a little bit, just not right now. Let's name these triangles. Let's name this ABC, triangle ABC, and we're going to name this XYZ. Let's see, which one am I going to make the X? I changed it a little bit. Let's make this the Z, and let's see, this is the X, this is the Y. Okay? All right, and what if I told you that angle A was equal to angle X? Okay? And what if I told you that angle B... Oh, let's... I think I did these in the wrong order. It doesn't really matter, to tell you the truth, but for what I'm trying to do, let's move that there. Let's call this one Z. All right. So let's say that angle B and angle Y were equal to each other. Now, if A and B are not equal to each other, but B and Y are equal to each other, what do I have to do to show that B and Y are equal? Do I put just one arc? No, because one arc would mean these two are exactly the same. They're not exactly the same, so I would put 2, just like Hunter said. All right? So angle B is equal to angle Y. Angle A is equal to angle X. Everybody good? All right, so what do you think you could conclude about angle C and angle Z? Okay, why? Just because it just seems like they should be? Yeah, they're the same triangles. Okay, that's true. But let's do a little proof, all right? And they add up to what? Actually, let me say this. Yeah. Yeah, what do all three of these angles do? They add up to what? 180. What do all three of these angles do? They add up to 180. So guess what might be true about angle A plus angle B plus angle C? No. That's only if it's equiangular, they'd be 60 degrees. But what could I say about angles A plus B plus C compared to X plus Y plus Z? They would be equal to each other as well, right? Would you agree? Any angles of any triangle, right, are going to add up to be the same as any angles in another triangle. It doesn't matter if the triangles are exactly the same or not. Agreed? All right. So what could I say then? Angle what? X plus angle Y plus angle Z. So that would be true about any two triangles. It doesn't matter if they look the same or not, right? But what do we know about this, though? Angle A and what? X are the same, right? You remember in algebra, whatever you do to one side, you do to the other side? Yes? Everybody with me? Okay, not or something. Do you remember in algebra, whatever you did one side, you do the other? Ah, there we go. All right, so if angle A and X are exactly the same, what could I do? I could subtract them from both sides. That's right. Okay, everybody see that? Because if they're the same, right, if that was 30 degrees and this was 30 degrees, what could I do? I could subtract 30 from both sides. Agreed? Because they're exactly the same. Well, so that would cancel out that one, and it would cancel out that one. If they're the same, right, they have to start off being equal to each other. All right. What else are the same? B and Y. So what could I do with those then? I could cancel those out. So I could subtract angle B and angle Y from both sides because they're both exactly the same angles, right? Again, if they were like 45 degrees, all right, I could subtract 45 from here. I could subtract 45 from there. They both would cancel out. Agreed? What am I left with then? Angle C now must equal what? Angle Z. And we thought that off the top of our head, right? We kind of looked at it and you're like, yeah, it kind of makes sense. But this actually proves it. This shows that it's actually true. It's a theorem. We actually proved the theorem. All right. Remember what I said at the beginning of the year, we're not going to do any formal proofs, but we will from time to time look at some stuff and actually prove that things are true. And that's exactly what we did. It's not technically a formal proof. You don't even know what a formal proof is, but don't worry about that. All right. So there we go. So angle C must equal angle Z. So we have a theorem and it says this. It's written in the book. It says if two angles of one triangle, right here, are equal to two angles of another triangle. Do we have that situation here? Do we have two angles on this triangle equal to two angles on the other triangle? Yeah, I got this one. It doesn't mean that these two are equal to each other. It just means these two angles are equal to the two angles in the other triangle. Yeah? All right. So if you have two angles of one triangle equaling two angles of another triangle, the theorem says that the third angles must be what? Equal to each other. Okay? So if you were given that A and X were equal, that B and Y were equal, what can we say from this theorem? We can say that angle C must equal what? Angle Z. Everybody good with that? Yeah, that's not too hard to understand, is it? Let's do an example where we use this stuff. You're like, well, that seemed easy, but every time we do an example, then it seems harder. But I don't know, maybe it's the other way around. Maybe you think, I didn't really understand what you were saying, but then I saw the example, and yeah, that kind of makes sense. So let's do a triangle that looks like this. This kind of looks obtuse, so I'm going to make it look like that, and then go to there. And then we're going to have, oops, what's all that mess? Try later. Then let's go from here to here. All right. And we're going to put some angles in here. They tell you that this angle right there is 36 degrees. Oh, you know what? I completely drew this wrong. Sorry. Don't draw it like that. Let's do that. I don't know what I was looking at. Let's do that. And let's do this. There we go. Yeah, I'll keep the 36 right there. Sorry about that. This still doesn't look exactly, but it's close enough. It's closer than it was before. All right, so let's say that's 60 degrees right here. Let's say that's 45 degrees right there. That's all they tell you. And let's do this in a different color. Let's do this pink color. Let's call this angle 1. Let's call this angle 2. And this one up at the top is angle 3. Okay? What I want to do is I want to solve for angles 1, 2, and 3. Everybody with me? All right. So where do we start? Oops. Let's move this about right there. What do you think the easiest thing to solve for would be right now? Angle 1, absolutely, because I got 36, I got 60, and I don't know this. So it's a triangle. What do all three of those add up to be? They add up to be 180, don't they? So you could go 36 plus 60 plus what? Angle 1. What do they add up to? 180 degrees, right? So what could you do? You could add those up. What's that? 96 plus angle 1 equals 180 degrees. How do I get rid of that 96? Subtract it. right? And you might have been able to just do that in your head to begin with, right? Because you know they all add up to 180. So how do I find out what's left over? I just add them up, take them away from 180, and that's what we ended up doing here anyway, isn't it? Okay, what is that? 84. So angle 1 is 84 degrees. Let me put the 84 degrees right there. Everybody with me? Yeah. What about angle 2? Okay. Where'd you get 96 from? Yeah. Straight angle. Good. That's what I want to hear. All right. See that angle right there? It's a straight line, isn't it? Or a straight angle. How many degrees is a straight angle? 180. Right. It's a straight line. It's 180 degrees. So if I know one of the angles, right, I got two angles here that make that 180 degrees. If I know one of the angles, how do I find the other one? Take it away from 180. So 180 minus what? 84. Guess what we get? Now that looks familiar, doesn't it? Where have you seen that 96 before? Yeah, this part right here. Now watch. Come on. Don't lose me. I want you to see something because we have a theorem that's going to talk about this, okay? But we haven't done the theorem yet, but I want you to see. Look at this 96. What's another way I could have gotten 96 instead of taking 84 away from 180? How did it get the 96 to begin with? How did I get that 96 to begin with? I added up that 36 and that 60. Everybody see that? So that works every time. You watching? Oh, I almost forgot. We got new seats today. We'll do that at the end. All right. So look at the 36 and the 60. I could have just added them up and figured out that that angle right here is exactly the same as that. Is that true just because of the numbers that I picked here? It's not. It will always be true. We're going to talk about that in a second. Just keep that in the back of your mind, okay? Everybody see that? See this angle out here? That's 96. How could I have found it? I could subtract it from this, but what if I didn't know the 84 to begin with? I could have found this angle right here, which we called angle 2. I could have found it just by doing what to these two numbers? Just added them up, okay? You'll see that in a second, all right? Now, how can I find angle 3? Yeah, just add the 96 and the 45, okay? And then do what to it, though? Take it away from 180, that's right. So, what's 96 and 45? That's 11, that's 3, that's 1/4, is that right? 141. And then what do we do with it? Now, that's 141. Does that mean this angle right here is 141? No. What do we have to do? We have to take it away from 180. And then what do we get? 39? Yep. So this angle right here is what? 39 degrees. Now, there's no other like quick little way to do that like we did that 96. Remember, we took 84 away from 180 to get it, or we could have just added those two up to get the 96. But that's the only situation. Well, actually not. What's another? Look at this. Here, this leads up to what we're going to do here in a second, okay? Look at this 84 degrees. Do you see anything else? Another way you could have gotten 84 if you knew this one? Look at this 39 and this 45. Do you see it? What do they add up to be? What's 39 and 45? 39, 45. What's that? That's 14, that's 7, and that's 84, isn't it? So check it out. Now, not everything adds up to be this, but look where that angle is in relationship to this one and this one. It's actually not in the triangle, is it? This 84. It's outside the triangle. We call that an exterior angle. Remember the beginning of the year we talked about interior exteriors? So this is actually an exterior angle, and these are the two angles that are further away from that 84. Do you see it? Look at the 96. On this triangle right here, this 96 is an exterior angle to this triangle right here. But how did we find it? You took the two angles that are further away from that 96, you added them together, and you get that. All right, so they did that example to lead you up to what this next thing is, and this is it's a theorem. And let's do this in white. So once we get this done, we'll do one quick example, and then we'll be good. Here's the situation that you're going to see every once in a while. All right. And let's name these angles. Name this angle 1, 2, and 3. And we'll call this one on the outside 4. All right. Angles 1, 2, and 3 are interior angles. Why? Because they're what? Inside the triangle. Angle 4 would be considered a what? Exterior angle, because it's outside the triangle. Okay. Now, these two angles right here, they're further away from the exterior angle than angle 1 is, right? You guys know what a remote control is, right? Remote, the clicker, whatever. Back in the day when I was your age, I didn't even have a remote control. We didn't even own one. Did I? Maybe I did. Well, when I was a little younger anyway, we didn't have a remote control. You know the horrors of living back when I was young? You know what we had to do if I wanted to change a channel? I had to get up off the couch, walk over to the TV, grab the little knob on the TV and go click, 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 and then go back and sit down. That's what I had to do. Isn't that horrible? Aren't you so glad you don't live in the dark ages like I did? All right. I'm just kind of joking, but it is true. We had to get up and do it. And then they came up with this remote. It used to be the remote was wired to the TV. We never had one like that. We had friends that had one, but they were kind of fancy. I'm like, wow, you don't have to get up off the couch. All you can do is click the button and it'll go to the next channel. It was amazing. So anyway, remote controls. Because you can be what? Farther away from the TV and change the channel, correct? Back in my day, I had to get close up to the TV to change the channel. But with a remote, you could be far away from something and click it. Like my camera, my big fancy camera, I can actually operate it through my phone. So I could be very far away from it and then actually see what my camera sees through an app on my phone. Okay, it's remote. Everybody, you know what remote means, right? So what am I getting at here? I just didn't want to talk about the old days and old TVs. These two angles are farther away from angle 4 than angle 1 is. So they're not just interior angles. What do you think we're going to call them with all that story? Remote interior angles. Okay, so that's a remote interior angle. And so is angle 3. That's also a remote interior angle. Remote to what? Remote to the exterior angle, angle 4. Everybody see that? Now, we just did a lesson. What happened? Look at the 96 and look at the 36 and the 60. The 36 and the 60 are what kind of angles to that 96? Remote interior angles, okay? And what did you do to those remote interior angles to get 96? Added them up, okay? Look at 84. What are the two remote interior angles to angle 84? Remember, this got to be the exterior angle. So I've got 3 angles inside this triangle. Excuse me. Which ones are the remote interior angles? The 39 and the 45. Do you see that? Okay. So our theorem says, well, let's write it down. Here's the exterior angle, angle 4. What does that equal? It equals the sum. What does sum mean? You add stuff up, right? So the exterior angle is the sum of the remote interior angles. So which ones are my remote interior angles? Angle 2 and angle 3. Everybody see that? So that's what the theorem says. I'm not going to write it down, but it says the exterior angle, which is angle 4, right? That's the exterior angle. The exterior angle is equal to the sum of the what? Of the remote, I'll call it just RI, is that all right? So the remote interior angles, to the 2 remote interior angles. And that's what our theorem says. Everybody good? All right. We could go through a little bit of a proof here, but we kind of showed it on the example, so I'm good enough with that. So let's do an example real quick here. We only got a couple minutes. But we'll be finished with this after we do this example. This is example 2. All right, so this is 64 degrees. This is 5x plus 3 degrees. And this is 13x minus 5. Oops, 13x minus 5 degrees. All right, and you basically want to find what the other angles are. Because right now, I only know one angle, don't I? That looks like that's a degree symbol, 64 degrees. It's not 640, okay? 64 degrees. So what does our theorem say? Let's do it real quick because we only got a minute left. What does the theorem say? The exterior angle is equal to what? The sum of the remote interior angles. So here's the exterior angle. It's equal to the sum. What does that mean we do? Add up the two remote interior angles. Well, these are the only two angles they give us, and so we add those up. So 5x plus 3 plus 64. Everybody with me? All right. I'll let you do the math. You do the math, solve for x, and you get 9. All right. I'll let you do the algebra. And so how do I find the other angles in here then? Just plug it in, right? So let's plug it in for this. What do I get? 5 times 9 is? 45 plus 3 is? 48. So that one would be 48 degrees. Okay. How could you find this one? You could find this a couple ways. You could just go, what? 64 and 48, then take it away from 180. Okay. They even ask you that angle? Yeah, they do. And that would be, actually, you could do it another way too. You could put 9 in for this and then subtract 5. So this angle on the outside is going to be 112 degrees. And then you could find this angle right here. I don't even think they ask you for that. No, they don't even ask you for it. But what if you wanted to find it, though? Okay, you just take 180 minus 112. And what is that? 68 degrees, right? So this would be 68 degrees. So there's all your angles. You just found it, okay? Everybody with me on that? All right, so now you can start on your homework. Remember, on Friday, I said, or whenever it was, did we have, no, we had teacher thing on Friday, right? So on Thursday, I said you could start on section 4.1. Anybody actually do that? Yeah, I didn't think so. Well, now you got to do them all. So if you would have started on Thursday and do a few of them, you could have had some of them already done. But that's okay. There's not that many. 16 problems. That's your homework.
What are the new seats?
The new seats. Just remind me tomorrow. I'll tell you what your new seats are tomorrow.